listen to that. Okay. So before I talk about what I do now, I'll take a step back and sort of show you some pictures of me when I was little. So I didn't always know that I wanted to be an engineer. There were actually a lot of different things that I wanted to be when I was little. I thought maybe being an astronomer would be really cool. This is a picture that a space telescope took of some galaxies, or well, of some nebulae. So this is where stars are born. This was is a very famous photo. It was in a magazine and I saw it when I was about 5 or 6. And I thought maybe I'd be an astronomer when I grew up. I always loved being in the water. So even though I'm from Kansas and wasn't near an ocean, I still loved being in the water and going swimming. So I thought maybe being like an Olympic athlete would be cool, or being a marine biologist. I've always liked to write. Being a geologist, we went on lots of trips to different national parks as a family when I was growing up, which was a fantastic experience just to see all the different things that are in the country, but just also gave me a lot of opportunity to learn more about different types of science when we were in different national parks. And then again, because I'm from Kansas, we had family who, live out in more rural areas. So I saw lots of rodeos. I was able to participate in a rodeo at least once. So I thought being a barrel racer when I was 13, my dream was to be a professional barrel racer. And then I did ballet for a really long time as well. So I thought being a ballerina would be cool too. So you can see I was kind of all over the place. I had lots of different interests. I wasn't really sure what I wanted to do. But I always liked math. I did always like science. And that sort of eventually, as I kind of meandered and tried to figure out what I wanted to do, led me to becoming the engineer that I am today. Okay. So I already said I'm from Kansas City. I think hopefully everybody knows where Kansas and Kansas City is, but you can see here, it's right here in what I affectionately call the heart of America. So we're right here in the middle of the United States. That's me as a baby. We already talked a little bit about what this picture was, but this is the picture really that kind of inspired me to pursue space, either to be an astronomer, be an astronaut. I didn't really key in, as I already said, on engineer until I was older, but I always thought that space was really, really cool. And it was in large part because of this photo. I went to the University of Kansas for college, so I'm a Jayhawk. And when I was in college, I was involved in a lot of different organizations that I can talk about later if anybody has questions about that. I also went to France for a semester, so I got to study abroad and speak French, which was really fun. I worked at a company that makes airplanes after I graduated from college for one summer, and that was really fun. Then I went down to Texas and I got a master's in aerospace engineering. So 4 years of college wasn't enough. I wanted a little bit more. So I was in school for 2 more years to learn more about aerospace engineering. And when I was there, I actually did some cool earth science research. So I tried to figure out better ways of identifying droughts in the United States. So that was really fun. Not at all what I do now, but still a very interesting experience. And now I'm out here. So the Jet Propulsion Lab is in the Los Angeles area. And this is a photograph from my first week of work. I joined a project called MAVEN, which is an orbiter that is orbiting the planet Mars, studying its atmosphere. So you can see the team members are here. I was new, so I didn't get a mission shirt, which is why I'm in that gray shirt instead. This is a photograph from later in my career. This was back in 2018. I was working on a mission called InSight, which is a spacecraft that we flew to Mars to land on the surface and learn more about what the inside of Mars is made of. So this was the day that we were landing on Mars. And then I also got to work on a mission called Mars 2020, which hopefully a lot of you are familiar with or maybe have heard about in the news. So this is the most recent spacecraft that we've landed on Mars, and it landed back in 2021. So it's actually on Mars right now, today, and it's already been there for 2 years already. So this was a photograph from when we launched, and we launched it in 2020, which was, of course, right in the middle of the pandemic. So in addition to having this cool launch shirt, which is what I'm wearing right now, we also had cool launch masks that we got to wear when we went into work to make sure that we stayed safe as we were working. Oh, and this is from landing day. So you can see still, back in 2021, still in the pandemic. So we still had masks, but they were special landing masks that day. And someday I would love to go to Mars. I think that'd be really cool. I don't know if any of you are interested in going to Mars. If you are, you can let us know in the chat. I always say that if I do go to Mars, I would want a round trip ticket. I don't want to live the rest of my life at Mars. So I would go there, but I'd want to come back to planet Earth for sure. Because my one Wizard of Oz and Dorothy reference, since I am from Kansas, there is no place like home, no place like planet Earth. So I would want to make sure that I get to come back. And so now outside of work, I showed you that when I was little, I like to do a lot of different things. And even now that I'm grown up, I still like to do a lot of different things. So outside of work, I'm a pilot. I fly small airplanes. They seat 4 people. So this is flying over the desert in Southern California a couple of years ago. I like to hike and be outside. So I don't know if anybody recognizes this photo or if anybody's from the North Carolina area, but this is was taken in Great Smoky Mountains in that national park last year when I was on vacation with my family. So I don't know if any of you guys like to hike or be outside, but that's something I really enjoy doing. I camp too. So when I camp, I actually don't even sleep in a tent. I sleep in a hammock. Sometimes it gets cold, so I have to wear my fun camping hat. But I like to do that and be outside. I already said I like sports a lot. I like to watch them. So I'm a Royals fan, which is hard this season because our team's not doing very well. But I also am a big runner. So I've run 3 marathons and I still run. I'm recovering from an injury right now, but I still run a couple times a week, much shorter distances just to be outside and to stay healthy. I really like dogs. I don't know if any of you guys have dogs or have other pets like cats or fish or turtles or iguanas or birds or something even more exotic than that. I don't have any dogs because the apartment that I live in California doesn't let me. But when I work remotely, like when I've worked at my parents' house, I have some people or some animals that sometimes help me work. This was my sister's dog who sat in my lap one workday while I was trying to write some code. And then my parents have a German Shepherd and she will sit at my feet sometimes. So I love dogs, even though I don't have one right now. And then one of my favorite foods is barbecue. Being from Kansas City, I don't think you cannot like barbecue. So this is some burnt ends and French fries, one of my favorite meals of all time. So I don't know if there are any other barbecue fans online, but that's one of the things that I like the most. And I showed you kind of what my office looks like. And this is what my calendar looks like. I always think it's kind of interesting just to sort of see. I get a lot of questions like, what does a day look like for you? Or do you have a lot of meetings? And the answer is that it depends. So you can see that right now we're here today on Thursday, May 4th. So I went to a meeting over my lunch. Whoops. I went to a meeting. We're going the wrong way. Over my lunch break today, I'm meeting with you guys today. Yesterday, I had some different meetings. So this was actually a pretty light week. I didn't have a ton of meetings, but next week, I'm doing a mission test for one of the missions I'm working on. So I have a lot more stuff going on. So that's a little bit about me and kind of some of the more kind of, I guess, background details of kind of what my office looks like, what my schedule looks like. And now I'll talk a little bit about what JPL does and what I specifically do at JPL. So since we have a national audience, before I talk about JPL, I wanted to make sure everybody knew that NASA actually spreads coast to coast. So JPL, of course, is down here in Southern California. I've already mentioned that, but there are NASA centers elsewhere in California. There are some there's one in Texas, down here in Mississippi, in Alabama, in Florida, in Virginia, in Maryland, in Ohio. So NASA is not just, you know, something that you can do if you live on the West Coast or something that you can do if you live on the East Coast. But it's all over the country. And as you know, I've already said, you know, I'm from right here in the middle. And even though I didn't grow up near a NASA center, I've still ended up working at a NASA center. So you don't have to grow up next to one to end up working for NASA, but there are a lot of NASA centers around the country. And then our headquarters, of course, are in Washington, D.C. So where is JPL? Just kind of zooming in a little bit. So it's in the Los Angeles area, but it's kind of on the north side of the LA metro area. Orange County and Anaheim is down here. If anyone online is more familiar with Los Angeles. Zooming in a little bit further. And then here's what JPL actually looks like. This is an older photograph. There's some changes to what these buildings look like, but generally this is what JPL looks like. So when I first moved out to California, as I already said, I'm from Kansas. I didn't know that there were all these mountains right here. which is kind of funny for me to say out loud, but I knew that there were mountains elsewhere in California, but I didn't know that there were all these mountains right here in Southern California. So this was really cool. You know, I'm from Kansas. Kansas is flat, scientifically proven to be flatter than a pancake, actually. So having mountains right next to work is very cool. I can go hiking over my lunch break or after work in these, you know, kind of foothills back here. And over the winter, if it rains, we do get some snow like this, which is kind of cool. So this is the building that I work in. And I already showed you the pictures of my office at JPL, but you can see them again. So now that we know where JPL is, what does JPL do? So our overall mission statement, kind of the thing that JPL tries to think about whenever we decide to do a mission or build a spacecraft, is to build something that will help us explore space in the pursuit of scientific discoveries that benefit humanity. So that's a really broad statement. It's kind of maybe hard to relate to and really understand what that means. But essentially, it means that JPL wants to build spacecraft that can help us learn about our solar system. And in learning about our solar system, we can better understand our own planet and how we interact with our planet and all of that good stuff. So we've sent spacecraft to all of the different planets in our solar system. We've sent them to comets, we've sent them to asteroids, we've sent spacecraft to the moon, we've sent spacecraft to the sun. So these are pictures showing different missions I've worked on. I already talked about InSight. This is the spacecraft that we sent to Mars to learn about the interior of Mars. This is a picture of Europa Clipper, or an artist's drawing of Europa Clipper. So it's a spacecraft that's going to go out to a moon all the way out at Jupiter. It hasn't launched yet. It'll launch next year, but it'll learn more about this moon. This is another mission I'm working on called Lunar Trailblazer that hopefully will launch later this year. That's going to be looking for water at our moon. And then these other two down here, this is Psyche. This is a spacecraft that we're going to send to an asteroid. And then this is a cool mission down here. This is a spacecraft that we crashed on purpose. It wasn't an accident. We crashed this spacecraft on purpose into an asteroid. And if there are questions about why you would do that, I can talk about that later too. So if that's what JPL does, what do I do at JPL? My job is navigation. So I'm trying to figure out how you get from one place in the solar system to another place in the solar system. But before we talk about how you do that in space, let's think about how you would do navigation here on planet Earth. So I'm from Fairway. That's the part of Kansas City that I'm from. So if I was trying to get from JPL to Fairway, how would I do that? Well, I'd probably pull out my phone and I'd say, hey, Google, I want to drive halfway across the country. How can I do that? And so Google would come up with a route that I could drive, and I would hop on these different highways. I'd take I-40 all the way across Arizona, across New Mexico, and then I'd pop on this different highway and continue driving up to Kansas City. So that's one way that I could get from JPL to Kansas City, just one way. And that's just by car, right? There are other ways that if I wanted to drive, I could drive there. I could go further north and drive through Las Vegas and then pick up I-70 and take this highway through Colorado and through Kansas. I could take this different way. If I wanted to take a different mode of transportation, I could do that too. So I could take a bus, I could take a train, I could even walk. It would take me a really long time if I wanted to walk, but I could do it, right? I could take an airplane. And so when I'm thinking about all of the different ways that I could get from one place to another, I'm thinking about how much money I have to get from one place. An airplane ticket's more expensive, so maybe I don't have enough money to fly, but I have enough money to drive. Maybe I only have a certain amount of time, so I want to fly because I don't have 25 hours to drive from LA to Kansas City. I need to get there in 2 hours. Maybe I have a car that's really old and I'm not sure that my car can drive fast enough on the highway all the way over. So instead of taking highways, I'm taking, smaller roads with slower speed limits. So you think about a lot of different things when you're trying to figure out how to get from one place to another, just when you're driving around here on planet Earth. So you can imagine that if you're trying to get from one planet all the way to a different planet, you have to think about all that same stuff and even other stuff. But you can't just pull up. Ooh, I have an echo. Maybe now it's stopped. Okay, I think it stops. But you can't just pull out your phone and say, hey, Google, how do I get to Mars? Google doesn't know how to get you to Mars. So instead, you ask a navigation engineer like me, and it's my job to figure out how to get you to Mars and then make sure that you don't get lost once you've started flying to Mars. Because if we go back to that example over here, whoops, spoiler, if we look at this example again, even once I've left JPL and have started driving to Kansas City, I'll still continually check the map for updates because maybe there's an accident in Albuquerque that is causing a really big traffic jam, and I take a different route to avoid getting stuck in all this traffic in Albuquerque. So even after I've left, I still want to know where I am and get a sense of what's on the way to my final destination. And the same thing is true when you're flying from one planet all the way to another one. So now this is some other fun stuff. So now that Perseverance, the rover, is at Mars, what is it doing? It's been there for 2 years. Has it just been sitting in one place, like taking pictures? No. Perseverance has been doing a lot of really cool science. And one of the really neat things that it's done has been collecting these rock cores or these samples of rocks at Mars. So this is a really close-up photograph that the rover took. So the rover has a lot of cameras on board, and it will take pictures and then send them back to the Earth. And so this is a picture of a piece of a core of rock that the rover collected. And it's about the size of a piece of chalk, or about the size of your index finger. I don't know that anyone uses chalk anymore, but it's about 2.5 inches long and about 1/2 inch in diameter. So it's not very big. And if you then don't look at it in quite so up close, you can see that we put all these rock cores in these sample tubes, and then we dropped these sample tubes, these 10, on the surface of Mars. And so Perseverance itself is not going to bring these samples back to the Earth. Perseverance won't ever come back to the Earth. But a future mission that we're going to send to Mars will collect these samples and bring them back to the Earth for scientists here at the Earth to study. So it could be one of you guys. If you're interested in learning about rocks at Mars, it could be you guys. We won't be able to bring these samples back for a while. Probably 2033. So that's 10 years from now. So some of you may be old enough that you're starting to get into high school or college. And if you're interested in studying rocks from Mars, we have the samples just waiting to come home now. So these are where they are on Mars. Those same 10 that I just showed you, we drop them in different places, and there's kind of this zigzag pattern to them so that we can pick them up safely. And they're in this Three Forks sample depot on Mars. That's where they're all located. So this is the last chart I have, and it's always one of my favorites because it doesn't take one person to get to Mars. It doesn't take 10 people. It doesn't even take 100 people. It takes thousands of people to working together to build something that you can then send to Mars and then use to perform all of these cool science experiments and all of these sample collections. So it takes a lot of people working really hard, working together, and working with Perseverance, working to overcome obstacles to ultimately achieve their goal of sending a spacecraft to Mars and then collecting samples and looking for signs of life at Mars. So thank you very much. I hope I didn't go way past my time limit, but I'm happy to answer questions if there are questions too.
Sarah Elizabeth, thank you so much. That is so exciting. Maybe as much as I love here, project scientists, maybe on the side, I could just stop on over at Mars and grab some of those samples for you. I hope you are all so inspired as well. If you have any questions for Miss Sarah Elizabeth, if you want to put them in the chat, we do have a couple of minutes before we do our rocket build.
No, I'll go ahead and stop the share so I can see anyone too.
You can also use the raise a hand feature on Zoom if you want to raise your hand and we can call on you to ask a question. Oh, I see a raised hand already. Fantastic. Is it Jimin? I want to make sure I'm saying that right. So when you unmute, you can go ahead and unmute, and if you'll pronounce your name properly for me.
My name is Jimin, And I have a question. It's will the samples be available like to like public when they come back from Mars?
Hi, Jimin. That's a very good question. So when the samples come back, they'll be available to scientists, kind of like when we bring the moon samples back. So certain people were able to actually touch them and perform experiments on them, but I couldn't have just gone up to a moon rock and say, hey, I want to perform an experiment on it, but I was able to see it in museums. So I don't know exactly how they will treat the Mars samples, but I imagine they will be very, very valuable. So I know we'll make sure to treat them very carefully. So I think trained scientists will be the ones who get to work with them and interact with the samples, but hopefully they'll have smaller versions that the public can see as well, because I think that'd be super cool. Good question.
Thank you.
I saw Abigail had her hand up, and then I see a few that we can answer in the chat as well. We'll take about 3 or 4 more questions. Abigail,
Yes.
go ahead.
So is like the thing that you like take to Mars, is it like metal, plastic? Like how do you like how does it feel and like what's texture is it and like what do you use to build it with?
Yeah, that's a great question. So like, what is the spacecraft itself made of?
Yes.
Yeah, the very good question. So you can imagine that the spacecraft has lots of different parts, and each of those parts is made up of something different. So this particular spacecraft has wheels, and the wheels are made of aluminum, the same stuff that your soda can is made out of. So the wheels are made out of aluminum. They're connected to the body of the rover with titanium. So that's a stronger metal. Sometimes when people have to have implants into their body to help their bones heal or help their bones, be held in place, sometimes those things are made out of titanium. There is gold on the spacecraft, which is pretty cool. So gold is really good at keeping heat in space. And so there are very small parts of the spacecraft where that's a valuable characteristic to have. So there's some gold. There is some plastic. So it's a lot of different material. And then there's some glass too, because we have cameras. And so you want to be able to, see through the camera lens as well. So all of the things that this spacecraft is made of are all materials that are available here on the Earth. We maybe treat them a little bit differently, so the materials are safe in outer space, but they're the same materials that we have here on the Earth. So it's a good question.
It's wonderful. I see a couple different ones in the chat kind of talking about how many people it takes to make the rocket or to get into space, and really kind of the roles and jobs of different people in those projects.
Yeah, so it's a good question, and that's kind of what I was trying to show with that last photograph. So that last photograph that you saw, where there were probably at least 1,000 people in that picture. Some of us were engineers who were helping fly the spacecraft to Mars. Some of them were engineers who had built the spacecraft. Some of them were scientists who weren't going to start doing their jobs until the rover landed on Mars. And that was just the people working on this project at JPL. We launched on a rocket, as someone probably noted in the question. And so the people who built that rocket were working at a different NASA center in the United States. So there were hundreds of other people working just to build that rocket. There were hundreds of people at the NASA center in Florida to safely install our spacecraft on that rocket. So it takes a lot of different people in a lot of different parts of the country, all working together. And another question that I often get that's related to that one is, that's kind of how many people, but, how long does it take to do a project like this? And so I've worked on this project for over 6 years. So I started working on it in 2015, 5 years before it launched, and then worked from when it launched all the way until it landed. And then since I successfully flew it there, I stopped working on it. And there were other people, who now have started working on it and have been working on it for years, doing the science at Mars. So to design and build and then operate something like this can, take 10 to 20 years, depending on how long you operate it when it's at its destination.
Wonderful. I'll pull one more question from the chat, kind of trying to combine a few of them. Kind of related to why are they so valuable? They're just rocks, but also kind of what do you do with those samples? Why is it important to study those rock samples?
Yeah, that's a very good question. Yeah, because you're right. I mean, they're just rocks. Like what's the big deal? Well, the big deal, number one, is that we've never been able to bring anything from Mars back to the Earth before. So one of the reasons that we like to study Mars is because Mars is a very similar planet to the Earth. So it's a similar size, it's a similar distance from the sun. And we know in the past, so not today, but a long time ago, we know that Mars had a climate that was very similar to the Earth, or at least it was a much warmer place than it is today. We know that there used to be liquid water on the surface of Mars. So in the ancient past, Mars had the right environment for life to exist. We don't know that life existed at Mars, but life could have existed at Mars. So one of the big questions that scientists have been trying to answer for as long as humans have been alive is whether or not we're alone in the universe. Are there humans? Well, not are there humans? Is there life, any kind of life anywhere else in the solar system? And when we talk about life, we don't even mean something as advanced as humans. It doesn't even have to be a plant. It doesn't have to be an animal. If you even just had a little bacteria cell, that still is life. And so we want to better understand what Mars was like a long time ago so that we could potentially find evidence of life in the past to then answer that question of whether or not we're alone in the universe. But as you might imagine, it's really hard to definitively 100% say with certainty, yes, we know that there was life on Mars. So if we can bring those rocks from Mars back to the Earth, it's easier for us to try to find that evidence because we can use the collective wisdom of all the scientists at the Earth. We can use all of the different lab equipment we have here on the Earth to try to find that extraordinary evidence that would help us make that extraordinary claim that, yes, we did find life at Mars. So that's one of the reasons we want to bring them back. And then we also are interested in studying Mars because if Mars used to be like the Earth, but now it's really, really cold and really, really dry and really inhospitable to life, could the same thing happen to our planet? We don't know. So we also want to study Mars so that we can learn more about our own planet to make sure that we can protect it the best way we can.
Oh, Miss Sarah Elizabeth, I know I speak for everybody when I say this was just such an exciting presentation. We loved hearing from you and your great questions. I think this could easily go on for another 5 hours. If you're on the East Coast, this will be far past your bedtime. Instead of I wanted to leave more time to have those questions and to have those conversations. So instead of doing our activity tonight, I'm going to go ahead and just walk through kind of the steps that you can do it on your own. And you have the template from your registration, or I'm going to go ahead and put the PDF in the chat as well. It actually comes from Jet Propulsion Laboratory and NASA. So we are excited to be able to share that activity with you. Sarah Elizabeth, did you want to hang on with us for a few more moments as I present that, or do you need to hop off?
No, I'm happy to hang on, and I know there are always lots of questions. This is how I'm rounding out my workday is chatting with you guys. So I have a little more time and I'll try to see if I can maybe answer some questions in the chat in the background too.
Oh, that would be great. Yeah, I'll present while she chats with you all for a little bit, and then we'll say maybe we might be able to answer one more question at the end as well. I'm going to go ahead and share my screen just to show you some of those steps that if you want to try out a fun STEM activity at home, that you have all of the resources to be able to do so, and so that you know exactly how to follow those steps. So included in that document that I put in the chat for you is a template. I'll actually go ahead and open that up really quickly so you can see that as well. But it comes with all of the directions that you can try this at home. It lists out the same materials that I shared with you. You'd need a pencil, some scissors to cut out paper, tape, soda straw, or I have even just my metal reusable straw here, either a meter stick or measuring tape, so you can collect some really good data and compare how your launches work different ways depending on your rocket design. And then this template is fantastic because not only does it have everything right there that you can just cut it out to build your own rocket, but it also has some really cool data pages that you can build it, test out your different launches, see how far they travel, see if you can change the shape of your fins, change the length of your cone, and if that changes your results at all, it's a really great experiment to kind of play around with. And then you can graph it if you're older. I used this page to just draw my design even of my rocket before I began. Oops, I'm always so bad with the background. I don't know if you can see it, but there we go. So you can use that paper really for anything that you want to. But the simple steps, just to go over it quickly with you, is you're just going to cut out that rectangle. You will roll it once you have that paper around the pencil. Now, I thought that was the trickiest part. So if you're going to try this later with someone, I would recommend grabbing a friend, grabbing a parent or a sibling or a grandparent or whoever may be home with you, because I had to have my 4-year-old son hold the paper down while I taped it. That was probably the trickiest part for me. So you wrap it around there, you cut out your fins and tape them on. If you don't have this template, it's fine to just cut out a rectangle, create your own fins. Triangles are great, but it could really be any shape that you wanted to explore, see if it makes a difference. And then you create your rocket. You'll bend the fins so they stick out a little bit more. It talks about a 90-degree angle, getting some good math in our science here, getting our STEM going. And then you will take your paper and kind of twist it at the top. If you just hold the very top and twist, it'll eventually kind of turn into a little cone. And it may be a really short tip or a nose cone. It might be a really long one, and that could affect your launch. I'm sure that many scientists working on Sarah Elizabeth's rockets that go into space could tell you more about the importance of that design. But you can kind of play around with it. And then from there, you just take it off your pencil, you put it on your straw, and you can blast it. I know that you can't see with the background there, but mine shot all the way across the room. I almost got my dog when I tried it out earlier today. So beware of any siblings or friends or dogs. You don't want to blast them with a rocket. But it's really fun to try out and to experiment around with and see what worked and what didn't work. Just like we know that scientists are doing all the time and engineers are doing all the time for these rockets. I'm sure Sarah Elizabeth, she mentioned she has a test launch next week. They're not just going to build it and then think it's ready and go on. You've got to test it and make it better and make little changes along the way. And I absolutely loved how she shared the importance of, you know, working as a team. And for all of you, you don't have to know everything. You might just know a lot about one thing. And when you work with other people that know a lot about something different, it all kind of comes together. So I love that importance of persistence and not giving up. Oh, that she just put it in the chat. I'll go ahead and stop sharing. We've got about 4 minutes left in our call that you can kind of read through the chat, or Sarah Elizabeth, if you wanted to expand on what you just wrote in there about that importance of patience and persistence, which is incredible in STEM.
Sure. So it's a great question, and it's one of those things that's easier for me to talk about than write down. But yeah, the idea of being patient and being persistent is something that's super important, not just for engineers and not just for scientists, but for everyone in whatever it is you choose to do. And it's really important in school as you continue to, you know, go through school and learn new things and try new things. There's this idea, I think some teachers probably are familiar with it, of something that's called a growth mindset. So the idea is that one of the best things that you can do when you're in school and just when you're trying something new is be willing to fail, which is hard because, it's not like no one wants to fail. No one wants to make a mistake, but that's really how you know that you're learning. You want to do something new. It may be something you've never done before. And no one should expect that you'll get it perfectly right your very first try. So it's important to try something. And then if you do fail or if you do make a mistake, to not give up and to change something and then try it again. And so I've made mistakes at work. I have failed at work. And so then I have to go back to work the next day and figure out, something new to try, or, come up with a different way of approaching the problem to fix it. And actually earlier today, I was working on a problem that I've been dealing with for over a month. I was writing some software and something just wasn't working, and I couldn't figure out why, because I knew that I had written similar software that did work for a different project a couple years ago, but I just couldn't get it to work, and I couldn't get it to work. And I had to, keep trying and keep looking at all these details. And finally, at about 3:45, about half an hour before I logged on with you guys, I finally figured out the answer, but it took me a month of work to get there. So that's just a very recent example. You just always need to be willing to keep trying, to not get discouraged when you fail the first time. I ski in the winter time. And I always, tell people that if I don't fall down when I'm skiing, I haven't tried something that's hard enough. I'm not pushing myself hard enough. So I'm not sure that that's the best example, because I don't want you guys to all go off and ski and then like fall down and break your leg. But engineering is kind of like that, right? Like if you're not doing, like if you aren't failing, are you doing anything that's interested? You're probably maybe not trying anything new. You're not pushing yourself past your comfort zone. You're not pushing yourself to do something that you haven't done before. So even though it's uncomfortable, there is a lot of value in trying new things and being willing to fail and then try it again anyway.
Thank you so much for an incredible evening learning all about what you do. You are such a wonderful role model as a woman in STEM. And we look forward to learning more about all of the future missions that you're working on.
That sounds great. Thank you so much for having me. This was a treat.